OpenMRS project. These gentlemen are two of the founders of a project which is aimed at helping out the public health space in the developing world. And without further ado, Dr. Bondage, Dr. Mamlin.
Thanks.
Hi. So thanks for having us today. And if for whatever reason you have some questions or want some clarity, please feel free to stop us and we can answer questions. We want to just give you a quick overview of what we're going to talk about today, who we are, how we got started on this project, 'cause I think having a little bit of the background, give you some context might be important, and what is OpenMRS and what exactly are we trying to do, and how we've evolved over the past 3 years, and some of the lessons that we've learned, in particular one big lesson that we've learned over the past 6 months or so, and how we intend to grow, and maybe end up with what our mission statement is to give you a sense of, you know, if you'd like to get involved, how you can get involved. So in full disclosure, I am a pediatrician, and I'm the guy who doesn't like to take care of the little adults.
And I'm the internist. Sometimes I say the real doctor. I take care of adult patients and don't do the little kiddies. Although I love kids, I just don't want to be their doctor.
But I think it's also important to acknowledge that at heart we are a bunch of geeks. I mean, so we just really love information technology, and we actually, thanks to this guy, who's actually the dishwasher king. His name is Sam Regenstreif, and he's this process engineer that was absolutely obsessed with trying to do things in more efficient ways. And he actually took his millions that he made and built this place called the Regenstreif Institute. It's a place that we work, and it's actually a brand new building that we just have, so we're pretty excited about it. But I think the best way to describe it is to show this picture. Does anyone know what this plane is? This plane was actually the first product of the Skunk Works. Do you folks know what a Skunk Works is? I mean, it's the whole idea behind the Skunk Works is that you put some people in a room and you unencumber them from all the bureaucracy and all the resources, and you get them to do something really incredible in a short amount of time. And they actually prototyped this plane for World War II in about 183 days. And so Regenstreif is kind of a place where we do medical informatics work. And so our job is actually to build these health information systems. And in our day job, the kind of things we do are building systems to allow clinicians to better take care of patients. And so this gives us some screens of the type of environment in which we work in. And some of the things that we actually do focus on things like decision support, so helping clinicians make decisions through information technology. And we also build interfaces to help clinicians better take care of patients as well. We wanted to give you a special sneak preview of our latest and greatest invention. We call it the Popcorn Man's PDA. It's a strap-on laptop. No, we're just kidding. So we do a lot of interesting things, and one of the projects that we were asked to be involved with was in Africa, and I think initially both Burke and I kind of wondered why they would want us to go to Africa. And there's a clinic there that had an access-based system, and they were needing to figure out a way to scale because they were effective in taking care of patients, and they needed to understand how to become more effective within this context. And so initially we weren't so sure what we were going to do when we got there, but eventually we agreed to go. And you might...
Can I jump in?
Yeah.
So what was happening in Kenya at the time is they had this access-based system. They had built a registration system for a clinic, and it worked very well for them. And they were actually very happy to, that they had created this electronic, record-keeping system, and it was flourishing in this one rural clinic. And about that time in the late 1990s, early 2000s, the pandemic of AIDS started, and they realized we need to focus on HIV. We need to start treating and dealing with this, and that they knew they needed to use some kind of electronic system to help track that. So they took this access system they had and started using that. And the issue that came up is that they were going, from a couple thousand looking in a year or two to going to tens of thousands. And that's what got us over there and saying, well, how can we deal with this? Because the truth is, with AIDS, it's a giant problem. I mean, there are over 40 million people that are dealing with it. And the factor, what's worth noting, is that about 5% of it is in developed countries, and actually it's 95% of the suffering that's going on is in developing countries. And so there's a massive need there. I mean, if this is the developed countries, I mean, that's AIDS in developing countries. So this is the face of AIDS, and it's worth seeing it. It's not, we don't want to be the Sally Struthers kind of thing where we're not. We want our community, and this is kind of a message also to our programmers that don't see it enough, is to know this is Musa, and he was basically dying. His brother brought him, carried him for an hour to a bicycle, to then ride him to a matatu, which is basically a van that carries dozens of people, to get him with over 2.5 hours to the hospital. And when he got to the hospital, he couldn't talk, and he had no blood pressure. So, but fortunate for Musa, this was when they had gotten some drugs and had some treatments for him, and they spent about 4 months working with him. And after about 4 months, Musa was able to walk all the way home on his own, and walked so fast that no one could keep up with him. And this is Selena. And Selena is, she was a special patient because she was a mother of 5 children, and she refused, she came in with PCP pneumonia, which is a bad infection, a bad pneumonia that people with AIDS can get. She refused to go to the hospital because she has 5 children at home, and her husband had died. And so they basically treated her at like an intensive care unit, put IVs in her all at her home, and worked with her. And yet, after treating her pneumonia, she still wasn't gaining weight. In this picture, when she started, she was about 32 kilos, so roughly somewhere in the 60, 70 pounds. And she wasn't gaining weight despite they had treated the pneumonia. They had her on the right treatments for AIDS. And then, a little light clicked, and they said, well, you know what, maybe we should feed her. And started, realizing that it wasn't just the fact that people had HIV, but they also needed a means to eat once they had, the medicines. And so just out of pocket, kind of feeding her and getting her nutrition, she's turned into a happy, healthy woman and taking care of her children. In fact, her story is special because she kind of started this program to then grow farms. And now the farms are feeding tens of thousands of patients. And they have a program where they graduate patients through that and teach them how to farm. So now, not only is she healthy and taking care of her children, she's independent and has her own farm. So the point is that these are real people, and while we can do this for Musa or for Selena, the point is there's 40 million stories like this, and so it's a giant problem. And with that comes an incredible need for infrastructure.
But I think the other important point is that it's a big problem, but it's a treatable problem. So we know what to do about HIV. We know that if we get people the proper medicine and the proper care and support systems, that we can actually help these patients. So the issue becomes one of scale. I mean, how do you can go and treat a patient and have individual success, but when you're talking 95% of the burden in a very concentrated geographic area that is very developed and very underserved, how do you go and rapidly build systems of care? And if you go and look at the current state, or at least when
this was about 2000.
About 2000, when we went to this location, this is a nice symbol for what the HIV care system was like. And if you think about care, I mean, information is really care. I mean, being able to understand what a patient's status is, it all kind of relates to the information around that patient. And so information management, especially as you scale, becomes extremely important. And so this was their information system when they started. So we're talking, paper files. I mean, it's a far cry from what can be done with information. And this audience, out of anyone, would understand the importance of that.
To their credit, this was one of the cleanest, most neatest medical record rooms that we could find. But I doubt many of those were accessed after they were filed away.
So we put this picture in because I think during the point of that, throughout that week, we once again, we came in as consultants, but I think we left kind of with our heart belonging to Eldoret, and we just felt like there was a need to be involved because despite everything that was going on in this place, you found people that had such hope, and they understand that there is a way forward. And so it seemed to us, given all the people that we've met that have dedicated their life towards working in this area, we could maybe spend a little bit of our time working on trying to build something that we know how to build, which is information systems. And that's what got us involved. We were hooked. So I think if you're wise and you're starting to build something like we're talking about, an information system to manage patient care, it's worthwhile to, before you start building it yourself, go and look and see what else is out there. And so there are other people that are interested in doing health information technology in the developing world, but when we went out, what we saw were a bunch of silos. I mean, so a lot of systems that were built not for any ill intentions, but they were built to meet needs, and they weren't built with scale in mind. And so we saw products that also had an important, the front end looked very impressive and sexy, but when you look behind the facade, you see not much infrastructure, not much ability to scale, and once again, you know, a real focus on the front end and the user interface. And so I think when we talk about what makes an enterprise quality system, you have to think about architecture and database architectures and how you store medical information. And the classic way that people start building health information systems is what we call a flat data model. And the idea behind it is you can imagine a patient as a row inside a table, and different attributes or different kinds of information about a patient, things like pulse and weight, are columns in that table.
So most people will, you know, often will pull out Access or Excel and you know, just to get things started, and boom, 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 column of every you know, observation, every little piece of information they want to collect on the patient.
So the question then becomes, if I have a new piece of information that I want to capture, how do I do that in my database design? And it's important to point out that, you know, as clinicians, we acknowledge up front that a lot of what we practice today is wrong. And a lot of what we do evolves over time. And so the need for a system to be flexible is really important, because as I start adding in things like CD4 counts, I could do the traditional approach.
CD4 count.
And oh yeah, CD4 count, I'm sorry, is a measure of immune power. And so folks with HIV tend to have suppressed immune systems, and a CD4 count's a measure of that. But if I want to add that information into my database design, what I end up doing is creating extra columns in my table, or I try to find ways to squeeze those columns in. But you can imagine the more information that I want to collect about a patient, the more that evolves over time. I start growing vertically, and I start running into problems with scale. And that's a serious problem in terms of being able to build enterprise systems.
Anecdotally, when we came to Kenya for this project, the system they had was exactly that, and they had exceeded the number of columns they could put into Access. And we're on their, I think, past their second into the third table, and you can just imagine the sequel they were writing to try to get, when each column is started on this med, stop this med, started on that med, stop that med. The sequel was just ginormous.
So early on, and these are lessons that we've learned during our day job, that there are different ways to model this same information and have much more effective scale. And so getting back to, so that's that flat model, that flat database model that we talk about. Imagine an alternate model, and where instead we take attributes and stack them, right? And so you have a separate table that has a dictionary of all the medical concepts of interest, and then you create one row per measurement. And so you can imagine that as you have new measurements, you create new dictionary concepts, and you separate the content from the actual database design. So that's, for those of you that are familiar or maybe not familiar, the entity attribute value database model design. And as you can imagine, as you start scaling that over time, you just grow the table, and it's from a database perspective, and just from database performance, you can grow a long table as long as you want, and you don't have the same performance issues as you would if you grow it wide. So I think coming in with those really basic premises, things that we didn't see out in the community, we set out to get started on this project. And I think our goals were to be flexible and to be scalable as well, and to maybe focus a little bit less on the front end, because clinicians have different ways in which they want to practice, and so there's different front ends for different kinds of workflows in different environments. And so if we could maybe focus instead on a foundation, so building a database design that's scalable, building an API on top of that, and separating out content in that database, then you have something that other people could maybe use and start from, and create a tide that rises all ships.
So one of the points there is that we envision that if we took the complexity of putting medical data into a database and wrapped it in an API and made that freely available to people to beat on, perhaps we could get everybody kind of working against that level rather than having to start from scratch. So.
Right. So I mean that gets to that notion of reusability. I mean you'd like to create an infrastructure that everyone is building upon versus building yet another series of silos. I think one of the drivers for Burke and myself, since we're both clinicians, is that we oftentimes in the community in the developed world see a disconnect between technologists and end users, and we have this unique role of being both technologists and end users. So we're both clinicians when we both practice, and we also do the development of the technology as well. And so it's really important from our perspective that people like us drive the functionality that the system has. And so we build our timelines and our guidelines and our point releases based upon what the community speaks of loudest, and we make active efforts to actually talk with the people that are in the trenches using these systems. So Burke and I work at the Regan Street Institute, but in order to kind of get to the point where we were an open source community or even think about an open source model, we wanted to bring some partners in, and we were fortunate in the next 9 months after we started kind of conceptualizing this to meet up with folks from the Partners in Health group, and in particular a guy named Hamish Fraser, and he has a team of developers that are doing implementations in a number of different countries. And I don't know if you've ever heard of Paul Farmer, but he's done a lot of important work in HIV and tuberculosis care. And so that was kind of the birth of a new partnership and a new relationship. And we had an interesting collaboration because we both needed each other. We both, in order to build enterprise systems, you really kind of need a lot of people to actually effectively scale that. And we are but 3 or 4 developers in Indianapolis and 5 or 6 developers in Boston.
So you take their team where they had already built a system in Haiti and in Peru, and were treating TB primarily. We're looking to go to Rwanda, wanted to rewrite their system. Here we are trying to build up a new system, thinking, how can we design this? And it was just a perfect kind of mashup of needs at the right time. And that was when I would say OpenMRS was born. And just a little plug, this is Paul's new son, Will. We're very proud.
Yeah, he's 10 weeks old, and I miss him very much.
Since we're showing family pictures, we wanted to show, I don't have a son myself, I wanted to show a picture of me when I was a kid, so. And we can skip by that one.
Yeah, so I just want to show you where we've come to. This is our database model, and we've iterated this over years. And so this is a reflection of a lot of content expertise, and once again, the notion is that we've abstracted out any notions of a particular type of care. So there's no HIV-related information in the system, but you can write the concepts into the database and use the system for whatever you want. So you can imagine it could be used as a tuberculosis system, as an HIV system, or as a general medical record system.
So in terms of kind of what this creature is made of, we are, and I think largely, I mean, we were looking at Python, we were looking at Java, we were looking at various platforms. Played a little bit in Plone, but the crew with Partners in Health had already built their systems in Java, had a lot of Java expertise, and we were kind of on the fence. And it was like, well, okay, there, choice made. And so our system is a web-based app built in Java. It has we're using MySQL on the for the database end, but we use Hibernate to kind of give us a layer above that so that we could use other relational databases. It's a Tomcat app, and so above Hibernate we have a service layer, which is where kind of all the business knowledge of our system is. And we're very careful to try to build such that Hibernate does not bubble up, and our business knowledge doesn't go down or work its way up out of the service layer. Trying to be fairly strict at maintaining those layers, because in the end it pays off. Like MVC model, when you finally get it, you realize, man, why weren't we doing this all along? So we're in Tomcat. We use kind of for a number of toolings within the system. We use Velocity. We use the Spring framework fairly heavily for internationalization for our MVC with the web, and we do some AOP for cross-cutting concerns, security, and whatnot. And on the web front end, we kind of bring it to life a little bit with using Dojo, and we've enjoyed DWR as well as a way to try to do a little more Java side stuff than a ton of JavaScript programming. And then recently we've been helped by BitRock to build an installer. We're working on a package that will allow people to get essentially a CD of the software and be able to install the system. While our initial aim wasn't at trying to be a plug-and-play solution, and we definitely takes technical expertise to manage an electronic medical record beyond just the software. But it does. We're trying to reduce the technical hurdles in terms of installing.
The current version of the installer is under 100 megs, and it packages up MySQL, Tomcat, all of the dependencies needed to literally open up a browser and start using OpenMRS. And so that's a good milestone for us, and we obviously have a lot of work to do. But once again, we're hearing from our users that that's what's important, and so we've put some energy into that.
So we also have a modular architecture. Ben, one of our lead programmer, was very kind to scope out and build us a module system that allows for plug-and-play modules to be added to the system, so that you can follow the standard API, kind of following the same pattern of Eclipse or other tools that are out there, even the plugins or add-ons in Firefox, to say, you don't necessarily have to get your hands dirty and get in the core. A lot of enhancements or little changes that need to be done can be done with plugging in a module. That really has helped us, I think, in terms of growing and flexibility-wise, because we've had fellows that are studying with us in medical informatics that have gone in and said, hey, I think I can improve the search algorithm for this or that, and been able to build a module that plugs that in without having to get all the way into the core.
Yeah, and the key is that there's a nice separation there, so they're not disrupting the base platform, but they can go and experiment and add features, and those could maybe be eventually assimilated into the trunk if we find a value in that.
So, and part of the point is that we have some domain knowledge. We're building a system that we hope can help the world out in the process, and but there's a ton of people that are underneath that are contributing in terms of all the libraries and things that help us kind of do what we need to do. And so we acknowledge that, saying that OpenMRS is just the tip of that.
Yeah, I mean, for lack of a better phrase, props to the open source community. They make a lot of this happen.
Yep.
So this is where we started, and this is Kenya, and this is a city called Eldoret, and where we had our first installation of OpenMRS. But what we've faced in these past couple of years is a pretty significant growth. And so we've got installations in a number of different countries, and a lot of people are implementing our software. And to be quite frank with you, at least at one point we had a thumb on exactly where it was being installed, but we get new inquiries of people. Like, for example, there was a fella in Haiti who has installed this into a hospital system, and he asked questions about the queries. He had put 400,000 patients into the system, and so we get these kinds of queries, and we're real excited about it because they come with good feedback and good answers, and it's clear that people are starting to find out about what we're doing. So we're dealing with this, this flock. I mean, we're all of a sudden we were started off in a small city in Eldoret, and we're starting to get a lot of attention now. And so as you can imagine, that we feel a little squeezed these days. There's a lot of interest, and I think all of you know that there's a difference between developing software and helping people implement the software and providing support around that. And so we've started to evolve a lot of notions of community. I think one of the watershed moments for us actually was the Summer of Code project, and Leslie and the open source team will refuse to accept any credit for this, but the Summer of Code experience was like shining a bright spotlight on our open source project, and it helped us in an incalculable amount of ways, and it's really kind of hard to describe in a couple of minutes, but it was a real light bulb moment for me, because I don't know about you, but if you follow the open source community, your perception, and my perception at least, is that people who contribute to open source projects contribute because they're benefiting from the products that they're improving. So they work with a product, they use it, they want to improve it a little bit, and so they contribute to kind of further the community. But we're building something that's a fairly niche piece of software. It's medical record system. And so most people that are working in the open source community, at least it was my assumption, wouldn't have the experience or wouldn't have the desire to be involved. And so, we applied to this Summer of Code project almost as kind of there's no way in heck this is going to happen, but we'll apply and see what happens. And we got accepted. We were excited. And then we figured, well, we'd maybe get 20 or 30 people to apply to us. We'd have a couple students, and it would be a great process. We actually had 150 applications or more. And we were really surprised. I mean, we didn't know what to expect from that. And I guess the lesson that we've learned over these past few months are that people participate in open source because they use the software, but they also participate because they have a philanthropic drive. They want to be able to do something that actually makes a difference and helps people in the process. And so, that was kind of a aha for us when we realized that we've been kind of working on our own because we felt like we benefited from the open source collaboration, but we really haven't tapped into the open source community as much as we can. I mean, we obviously take advantage of a lot of the platforms that the community has made available, but what we're starting to realize is that this might be a great way for us to be able to scale our development efforts. So this is, I don't know if you've ever seen one of these ant mounds, but this is how ants scale. They just keep building up. This has actually been one of our lead developers. So some of the things that we did, so we had a web presence, and quite frankly, it was built for us to communicate with each other. And so we have a lot of technologies that kind of make OpenMRS web presence hum, including a Subversion repository, track, forums, mailing lists, et cetera, but MediaWiki. But it lacked a lot of cohesiveness, and a lot of people, when they came from the Summer of Code, said, we have no idea how to get around. So that really kind of got us to think really long and hard about our web presence, and we did a complete site redesign. We opened it up a couple weeks ago, and we've got a lot of really good feedback. So thank you for that little stimulus. And one of the other kind of technologies that are underneath this web presence is RSS. I mean, so no matter whether you're posting on a blog or you're in a forum or in your mailing list or you're making a submission, a code submission, it's all being aggregated into a common RSS feed, and we do a lot of good work with tags so that people can go and filter that feed for whatever purpose they want. But we find that it works really well to increase communication and awareness of what's going on, because people like talking in different ways, and we don't want to preclude people from doing that. But one of the bad side effects of that is if you don't have a way to aggregate that information, there's lots of chatter that's going on that's not really touching each other. So the RSS has really kind of brought that alive, and we're real excited about where that's going to take us. Just a quick question to the community, and we're trying to learn a lot because we feel like we're fairly novice at all of this, and we're just flying by the seat of our pants more or less. But sometimes when it comes to the open source community, one of the big questions that I have is that no one wants to take credit for this work, and a lot of these communities don't really have people they identify as leaders. And so when one open source group wants to take advantage of a software but needs a couple tweaks done, we don't know how to communicate with those folks. And so that's something that we would hope to get some guidance on, and I hope you'll allow me the liberty to point out a couple of those groups in particular. We have a real interest in OpenOffice.org, and in particular the XML forms portion, and we've got a summer student working on this project to do data entry through OpenOffice forms, and we've actually gotten a pretty far away, but there's some technical issues that we would like to get some guidance on. So if there's anyone out in the community that represents OpenOffice X forms or knows someone, we would love to hear about that. In addition, I don't know if you folks are familiar with the Eclipse BERT, which is the business intelligence reporting framework from the Eclipse project. And we're using that because a lot of these healthcare environments need to report aggregate statistics about their care, and the Eclipse framework provides a really nice foundation for that. We've got another student working on integration of BERT into OpenMRS, and we would love to talk with people in that community as well. And then finally, I don't know if you folks are familiar with Pentaho, but they are another quote-unquote business intelligence group, but they do a lot of work around data warehousing. And so as you start looking and analyzing large-scale data, there's different ways of using OLAP technology to create shadows of that and be able to query it more effectively. And the Pentaho folks seem to have a good handle on what that's like, and we'd like to get some guidance from them if at all possible. So this is kind of a work in progress, and this whole notion of a mission statement we're starting to realize is pretty important, because I mean at some point you have to give the community and incoming folks to the community a sense of where we're headed. And we actually had a breakfast discussion about this very topic. So we have these mission statements, and they're kind of a work in progress, but we thought it'd be worth sharing as kind of our going away message. And I think our primary mission is to provide developing countries with enterprise health information systems that not only equal what we have here in the States, but potentially even surpass. I mean, because the needs are a little bit more acute there. And so we will not stop until we have systems that are of that quality or exceed that quality. And I think around that, our notion is different than a lot of other health information technology open source projects, in that we don't want to build it ourselves and then give it to the community as free software. We want it to be developed by the community. And so we're taking a very active role in building and fostering a community of people that are interested in building healthcare systems. And so we've had some success with that, but we're constantly working to get better at that. And I think what we found is that in order to really make these systems self-sustainable, especially in the developing world, it eventually has to be taken over by the folks in the developing world. And so we can affect change through this collaboration that we talk about, but I think we have to go a little bit further and also share our ideas and our knowledge with these folks as well. And we make a real concerted effort to try to get them invested in the work so that they actually are taking it and making it their own.
I'd add to that, it's easy to go into a place like Kenya and feel this kind of, I don't know, bias that, oh, we're going to go and kind of teach them something. But we've found quite the opposite, that the people we've met there and the people we've worked with have been some of the most lovely, brilliant people, and have actually been teaching us things, helping us improve the system. And the truth is, where the need is greatest, we need capacity. And while there are some real bright stars, there's a lot of kind of a gap in terms of getting knowledge and people that are willing to put the time in and get the training to especially, if we can get some, medically and geeky folks over there, it would make our lives a lot easier. Our goal is to become obsolete.
Definitely. So just real quick, just a couple groups to acknowledge. Our institute has put up with us going off and doing this harebrained idea that is crazy, but we're loving it. In addition, the Partners in Health group, Hamish Fraser. If it wasn't for Hamish and his team, we wouldn't have had this open source collaborative. So we really owe a lot to them, and they took a big chance to work with us. Because as anyone who's actually done collaboration realizes, there is a huge investment that's involved in it. And if you're having to meet deadlines to deliver things, there's a big challenge in making that work, working alongside other folks that have different motives and different interests. In addition, we have Chris Sebrex, who's a guy that works in South Africa at a place called MRC, and he has agreed and just blown us away by his generosity by leading an implementation community. And so it's one thing for us to sit and build the cool tools and build the technology, but then we have to have a team of a community of folks that will be willing to answer all the inevitable questions that happen when people start building the software. And where we started off, we had these mailing lists, and Burke and I would respond to all of these questions, and we'd have the developers. But it's amazing that whole conversations now are occurring about OpenMRS, and we're not even really involved in it. We just kind of sit back and just watch the communication. It's wonderful.
I don't think you can understate. I mean, for any coder out there, it made my knees buckle when Chris Sebrex said, I'd really like to coordinate the group of users and try to, when they have questions, think about what the answer and come to you with a solution instead of the question. And I'm like, are you kidding? I would wish a Chris Sebrex for every developer that's out there, because it really has made our lives so much better. We would lay down on train tracks for that guy. So yeah, he deserves
that's for sure. That's for sure. And then we also have fortunate support, not only just through resources, but also just intellectual and community support from the WHO, the CDC, and the IDRC, which is Canada's equivalent of PEPFAR. It's a funding source around the developing world in HIV care in particular.
Say what PEPFAR is.
PEPFAR is the President's Emergency Plan for AIDS Relief. It's our answer to HIV, and it's the funding source that makes a lot of the HIV care in Africa and the developing world happen. Yeah. And then last but not least, of course, Google. I mean, once again, I mean, I don't want to gush too much, but I mean, it was really a big help. I mean, probably one of the best gifts we've had is being made aware that there's a community of folks that are willing to actively help us build this software, and it transforms us into a completely different project when it's not 5 or 6 developers working on a piece of software. It really changed a lot.
It's fun, it's exciting, and a little scary when it goes from code development to community development. But
that's where we're at
a good
now.
ride.
Yeah, it's a good ride. So this is a screenshot of our most recent developers meeting or implementers meeting in Cape Town, and as you can see, we're kind of growing as a community, and it is breathtaking to be able to go to Cape Town and to see all of these people rallying around your software, and they kind of have a real interest in kind of making it their own and learning about it, and I don't know. It's just an unbelievable experience so far, and we thank every one of them for having the interest. It's pretty exciting. So, but that doesn't preclude you from coming to join the community. And in fact, we would welcome anyone to come and help us both identify how we can improve, but also kind of get directly involved in development. When we have a contribute tab on the top of our website that talks about a number of ways that you can do that, and we would welcome everyone. These are our email addresses, and we would love to hear from anyone out in the community that wants to learn more about our project. But I guess one of the things that we both feel pretty self-conscious about, we like giving demos, but we didn't know our audience well enough. But we kind of fell back on the idea that at any given point in time, you can go do your own demo. So there's an online demo of OpenMRS if you go to demo.openmrs.org, and the most recent alpha code is auto-updating on a nightly basis, so you can kind of see what the active development is, and so you can see our bumps and warts and our successes as well. But then, of course, you can go to our website to learn more about us. And that is it.
All right. Thanks, guys. Go ahead.
2 questions. What are the hardware requirements?
Okay. The question was about hardware requirements, and since we're basically MySQL with Tomcat running over it, and a WAR file, we run it on a laptop, so. I don't know. I would hesitate to say exactly this particular megahertz or this many gigabytes of memory. I would nowadays you'd say at least 500 meg or a gig of memory, but just any decent desktop machine could run it. When we run it for, in our case in Kenya, where we have tens of thousands, closing in 100,000 patients, and I think we're probably 15 million observations of those patients, and that we run on a server, a pretty decent sized server.
These are always notoriously hard questions to answer, because the question I would ask you back is, what is it going to be used for? And so if
I was wondering how it scaled with the number of.
So how it scales with the number of patients? Yeah, it definitely we got into this by having an implementation and working with an implementation, and our scale right now is tens of thousands of patients, and so we need it to work at that scale. If you go in and put like the fella in Haiti did, hundreds of thousands of patients in, you'll find.
We're learning a lot right now, because the government of Rwanda has. At least at this point, decided to use OpenMRS as their national framework for HIV care, and so we'll see on a countrywide level how it holds up. But we don't have the actual experience to be able to answer that question, to be honest with you. Yeah. I mean, we're kind of growing beyond what we had anticipated.
And we're really just at the verge of learning and experimenting with trying to distribute some of the work of the process, different processes, move the database separate from the app, and et cetera. So we're fairly small scale right now, so it's hard to say.
You had another question?
Another question?
Yeah, so do you ever encounter the problem where you'll go somewhere and they're still using one of those systems where it's like an Excel table with 6,000 columns, and then maybe they're convinced that OpenMRS would be better, but they say, oh, this is good enough, it works, we can't afford to switch. I mean, I think this is what the U.S., like a lot of U.S. health entities are encountering. So, I was wondering how you got around that, where you had to deal with that.
So the question was, and I think a good one, of a lot of people, if they have these systems that are Excel-based or an Access that have a lot of columns, they have a lot of data in there already, and they've invested in that, and they may agree OpenMRS might be a way to scale up, but do they want to invest the time, or is it worth it, or can they afford to? And I guess you might have some answers to this as well, but I would say, one, we're not really selling OpenMRS at this stage. So frankly, as we're riding the rocket ship, if people want to wait a little bit, I'm not going to cry. But at the same time, we're also working hard to build a version of it, working with WHO and CDC, that is easier to install. I think that, combined with lowering some of the technical levels to kind of get the system up and running, combined with the fact that as more implementers come on board that have some legacy data, they're coming up with new ways to import from an old system into a new. And as those get more flexible, I think the threshold it will take to switch over. One of our hopes is that if we can build a system that's fairly easy in terms of, just with some built-in content. At its basis, OpenMRS is it's the infrastructure, but the content of exactly what questions you're going to ask, what data you're going to collect, that depends. You could use it for malaria, TB, whatever. That really depends on the implementer. We often share concepts between implementations, but what we're doing with the WHO and CDC is saying, well, if we make kind of a packaged thing, say, we'll at least give you enough to get started with HIV care, is people could take that and use it to do kind of the simple day-to-day things they need to do, and hopefully start with that instead of Excel or Access. And then when they decide, hey, maybe we want to scale up, that package is the full OpenMRS, so they're already in a system that can scale up. So part of it is try to see if we can't at least give that as an option for people going forward. But there are challenges.
Trying to get back to one of the questions I heard from you was, if they already have data in the system, how can they get it into OpenMRS? I think is kind of what you're asking. Is that right?
Well, also I was thinking for U.S. hospitals.
Yeah.
I mean, even them, they have medical record systems, but they're frequently proprietary. Frankly, not very good.
Yeah.
Convincing them to switch to something better is almost impossible.
Yeah. So you're talking about one of my personal passions, and unfortunately, there's not a magic tonic for the problem that you're talking about, because I don't want to get too much on a soapbox about this, but deep underneath those databases that you're talking about come different notions of the same ideas. And so, for example, hemoglobin is a very common lab test, and a way one system actually records a hemoglobin is different than the way another system records it. And trying to make those concepts interoperable across systems is not something that can be done with any kind of magical statistics. I mean, there's some people doing some work on that, but the hard reality is that interoperability will never be solved until people realize it's a problem. And where we're headed, though, is that people are knowingly building up these medical record systems, but not knowing that the data that they're putting in the system isn't going to be able to communicate with other systems. And all we can really do at this point is try to create a system that doesn't fall underneath those traps, because we use standards, at least for our vocabularies. But I think we just have to raise awareness of what the problem is. And I think it's excellent to hear someone out in the crowd understand that, because that's, in fact, one of the biggest problems we have here in the States right now. So we talk about aggregating data for patient records, and that runs into all sorts of wicked challenges. That's what we do during our day job.
We have a two-word name for that: job security.
Yeah. Yeah. And we actually have a big. I mean, we won't be out of work for a long time.
So given that you guys are building up data sets that are in a consistent format from many different areas where there's different pandemics spreading, who's actually taking that data and doing any kind of public health analysis on it on the other side?
So that's a good question. So so most of these HIV care sites, they tend to have a funding source, and typically, at least as long as they're PEPFAR funded, they have a reporting requirement. And so these clinical sites are sending their statistics about how the quality of their care, they're justifying how their money is being spent by sending these data up, and they are being analyzed most of the time at a national level, so that there's ministries of health in each of these nations, and they take data. And we're working very hard with our OpenMRS framework, we're working with CDC and the WHO to try to ensure that there's a pathway from patient level data all the way up to aggregate statistics. And what's typically happened prior to systems like ours are that people, independently of managing their health information, they go and separately go and pull through records and try to create those statistics manually. And we're trying to create automated ways in which to filter those data up. So that's getting to the BERT stuff that we talked about, the Eclipse BERT. They have a lot of knowledge and expertise in that area, and that's why we want to take advantage of that community.
There's also communities, DHIS is a community in South Africa and Norway that is that works at the epidemiological level with indicators that are aggregate statistics, and we've got, we're kind of been talking with them for a while on ways to put the two together to try to meld between. We're very patient oriented, and then get up into the more aggregate or epidemiological stuff. There's a multi-country study being done that is trying to coordinate care of HIV among many of these countries, and OpenMRS is being used for a number of those sites. Yeah, I think that's.
What are you doing about patient privacy? Do you encrypt your data, or what are the protections? If somebody walked into one of these clinics and walked out with the box, are they walking with live data, or do they need to know some stuff to get at that?
We protect the box. We're not there's been some discussion in our among our community of different ways to encrypt the data. We don't have the expertise or resources to solve all that. What we do is anytime any of our system touches the World Wide Web, it's through SSL, and we secure channels. But if you got the box, you got the data. So please don't take the box. Okay.
I'm sorry.
A question of interest in a hosted solution.
Could you give me more kind of clarity?
Rather than have each.
Well, the big.
So yeah.
I think what
model.
you're getting is like an ASP model for the developing world.
Yes.
So of course the problem with that being that there's not great bandwidth in those environments, right? Many of those folks are dealing with dial-up, if that.
If they have power.
Yeah, intermittent power. I mean, there's a whole host of different luxuries that we just take for granted here in the States. But a lot of groups in the developed world are thinking about ASP models for medical record systems, and we work with a number of them. So, could we evolve to that if the bandwidth improved in that environment? Absolutely. I mean, we're a web-based framework, so everything that an end user does, with the exception of some content creation, is actually all done through the web. So
offline mode.
Like a disconnected data entry, or?
My thought is just that given the connectivity can be sparse in different regions, how do you accommodate?
Yeah. So.
It may be hard to get an internet.
Yeah. So the question is there an offline mode or a way to deal with disconnected states? And there's two ways we're cutting that. One is we have, like right now, where the way we're structured is docs are in the field. They don't have time for a computer, and so they're doing filling out encounters on paper, filling out just check boxes, and sometimes seeing 100 patients in an afternoon. And then those papers come to a central repository and get typed in by data entry people. Fortunately, it doesn't cost a lot to hire those folks, and it helps to employ people, so we're not jumping other than dealing with scale to try to replace all that. That said, we have one issue in these places where there isn't power or connectivity. How do we do data entry there? So that encounter sheet, the patient's chart doesn't have to travel away from the clinic. So if they come the next day, that visit's still there, and that we're working on a solution for that. And then the other is I think, more an issue for the partners in health group right at the moment, the way they're structured, but it's going to definitely be one for us is synchronization between systems. And we have a group, actually, some really bright minds working on that, trying to do it at a kind of a domain level with a transaction system, but to allow so that we can have several nodes and data can be kind of bidirectionally populated.
That's going to be one of the linchpins of this nationwide Rwanda system that we alluded to before.
And part of the goal with that is that it needs to be able to work on internet or sneakernet. So. Any other questions?
Thanks for having us, folks.
Thank you very much.
Thank you.